All right, we're in the home stretch now. The stuff that we're going to be covering now is not in your textbook. They do have a couple pages on it, but they don't have lessons on it. It was not in a chapter. They just assume this is something that you learned in middle school and you know it and you know how to use it. I have found that that's not the case, and you will actually be using this quite a bit in geometry next year, as well as in future math classes like Algebra 2. So it's a skill that you really, really, really need to know how to use. Now, when I say radicals, I'm talking about the square root sign. Okay, yes, we already did ones where you had the, we were finding the cubed root or the fifth root of something. We're not talking about that. We are just going to do the square roots when we're doing this, because the other ones don't quite simplify. And this is when you have a number that's not a perfect square underneath the square root sign. So the type of answer that I am looking for and that they will be looking for is this 2 square root of 7. You can say 2 radical 7. You can say 2 square root of 7, one or the other. That is a simplified form of the square root of 24. They are not looking for you to type this in a calculator and get a decimal. They do not want that. If they want, a monkey can do that. We don't want that. We want the simplified form. So there are a couple ways to go about doing this. I'm a big fan of the factor tree. Plus, we did it with prime factorization. We've already gone through this. So I'm going to do that exact problem to show you where they came up with that answer of 2 square root of 6. So what you want to do is you want to think of factors of 24. All right, so I'm going to go with 8 and 3. You want to use 6 and 4, 12 and 2. That's fine. You just don't want to use 1 and 24. Now, 8 is going to break down into 4 and 2. Again, you're just doing what we did before with prime factors. So this breaks down, again, these are my prime factors, and you can write them in any order, doesn't matter. When I put them in here, now what I want to do is I want to cross out any pairs that I might have. So I have a pair of 2s. I'm going to bring 1, 2 outside. It's like you're making a list of everything, any pairs that you have underneath. Sometimes, and we'll go over them in the rest of this lesson, where you have multiple pairs. Everything that you bring out gets multiplied. In this case, I only have 1 pair. So I'm just going to put 1, 2 out there. Even though there's 2 underneath, when you make the list, you only put 1 on the outside. And then what's left over on the inside, 2 times 3, and you clean this up by multiplying out the 2 and the 3. The other way that some people have gone about, maybe they taught this to you in 7th or 8th grade when you're doing this, 24, you want to think of the largest perfect square that goes into 24. The largest perfect square that goes into 24 would be 4. So when you take this, the square root of 4 times the square root of 6, the square root of 4 is 2, and then the 6 is not, it doesn't have anything, it does not have any more perfect squares in it. So that's another way. If you like that and you can visually see that, fine. Otherwise, you're making a happy little factor tree. So let's work with 32. Factors that go into 32 is 8 and 4. This would be 4 and 2, 2 and 2, and 2 and 2. So here I end up with 5 2s. So I have 1 pair, I have another pair, and I have 1 2 all by himself on the inside. Now, what you bring out, you multiply. Always going to multiply. Now, I know it doesn't make a difference if I multiply or add with 2 and 2, but regardless, you need to know that whatever you pull out, you're going to multiply those numbers together. Now, if you wanted to check yourself, you could take the original problem, type that in your calculator, you would get some ugly decimal. Then take 4 square root of 2, type that in your calculator, and you'd get the same exact answer. Same decimal. If you don't get the same decimal, you're wrong. All right, now let's do 300. I'm going to do 3 and 100. This would be 10 and 10, 2 and 5, 2 and 5. So underneath there, got a 3, a 2, a 5, a 2, and a 5. Now, sometimes circling helps you see all of the numbers. The other thing that would help you, the larger the numbers are, to go through this and take the 2 seconds in your calculator, 3 times 2 times 5 times 2 times 5, make sure you get 300. Now, a calculator is not going to simplify your answer for you. The calculator is going to give you this nasty decimal answer. We don't want that. So you have to do this part, the prime factorization, by yourself. So now, let's see, I got a 2 and I have a 5. So once again, what's on the outside, 2 times 5 is 10, and what's on the inside is just that's left over is a 3. If you have more than one number left on the inside, you multiply them, kind of like how I did right here. We multiply the 2 times 3 to get the 6. In this case, these last two examples, both of them only had 1 left over, so I didn't have to do any multiplying. Now, 64. 64 is special. If you don't already know what the square root of 64 is, the answer is 8. Okay? However, there's going to be some numbers, the larger they are, maybe you don't recognize as perfect squares. So, when you go to do this, and you break this up, I'm going to have a bunch of 2's. I'm going to have 6 2's total. 1, 2, 3, 4, 5, 6. So, I cross out a 2, cross out a 2, cross out a 2. Notice everything underneath the square root sign got canceled out. So I don't have a square root sign anymore. It goes away. And then I'm going to multiply 2 times 2 times 2, and that gives me 8 as my answer. All right, 1,296. That one's a fun one. So yes, it's a bigger number. A calculator would help you find factors, but that's about all that it's going to help you with. Now, one number you would always know when it's if it's an even number is the number 2. So you can always start with the number 2 if it's even. If it's not even, you'd have to play the game with your calculator and find a number that evenly divides in there. Again, 648, I'm going to divide that one by 2. 324, dividing you by 2. I get 2 and 162, 2 and 81, 9 and 9, 3 and 3. Okay, so I got a lot of numbers going on here. Let's see, 2, 2, 2, 2, 3, 3, 3, 3. All right, double check in your calculator. Multiply these out in your calculator because it's a larger number. If you accidentally forget a 2, maybe you didn't see this guy right here, it's going to make your entire answer wrong. So if you take the 2 seconds to type all of that in, make sure you still get 1296. All right, so I can take out a 2, another 2, another 3, and another 3. Notice this one, like the number 64, ends up being a perfect square. So when you multiply 2 times 2 times 3 times 3, you get 36. So the square root of 1296 is 36. Again, you may not always know right off the bat. 64 was an easy one. You probably could have done that in your head. 1296, maybe some of you could have done it in your head. That's great. I'm not one of those people, so I would have had to go through this to figure it out. Or maybe with the bigger numbers, take a second, type it in your calculator, and see if it's a perfect square. All right, now I've got where I have numbers out in front. So all this means is, notice I have a 4 already sitting out here in front, okay? All that means is anything that I'm going to bring outside, I'm going to multiply by 4. So I'm going to break down 125. That would be 5 times 25. 25 breaks down into, not 2, but 5 and 5. So again, I have a 4 waiting for me outside. 5 times 5 times 5. I can take out a 5, and I'm left with 20 square root of 5. Okay, in question number 7, now I have negative 2 out in front. So I'm going to break this down. 3 and 2, 3 and 2. All right. 2 times 3 times 2 times 3 times 2. Okay, I can take out a 2. I can take out a 3. I'm going to multiply negative 2 times 2 times 3, which gives me negative 12. On the inside, I have a 2 left over. All right, 3 times 81. Hopefully, you would know that 81 is a perfect square. The square root of 81 is 9. 9 times 3 gives me 27. Now, if for whatever reason you're in the zone and you're doing these problems, maybe you don't recognize that 81 is a perfect square. So, I've got a 3 outside waiting. And then when I go to do this, I can cross out a 3, cross out a 3. Everything underneath the square root sign went away. 3 times 3 times 3 gives me 27. All right, 120. Let's see, 2 and 60, 2 and 30, 5 and 6, 3 and 2. So again, I have a 5 already outside, 2 times 2 times 5 times 3 times 2. I can take out a 2, and that's it. On the outside, I'm going to multiply the 10, or 5 times 2, which gives me 10. And on the inside, I got to multiply 5 times 3 times 2, which is 30. That doesn't have a perfect square that divides evenly into it. Now, what I want you to go do is on the worksheet number 1, you are going to complete the questions. I want numbers. Actually, we're just going to go ahead and I'm going to have you do the even numbered questions before returning to Zoom.